welcome to the Counterpoint podcast. I'm Shubham Agarwal, and today we're going to discuss about the complexity within organizations and how do we simplify it. Often, the complexity of an organization is defined in terms of the number of divisions, the number of departments, or the functions that it encompasses, and the resources that it works with. And therefore, the perception that larger the organization, higher is the degree of complexity. In fact, we have observed in the past, while working with many clients at Vector Consulting Group, that whenever an organization fails to implement an improvement initiative, complexity is often quoted as a reason for it. And therefore, the belief that complexity is inherent in organizations. Now, that brings us to two important questions. Why is it that the organizations are considered complex? And second, how is it that we can simplify it? We have with us Achal Pande, partner at the Vector Consulting Group, who's going to help us demystify this and help us solve this. So let's welcome him and talk to him about it. Hi Achal, welcome to the Counterpoint podcast. It's always a pleasure to have you. So once again, welcome back.
Hi Shubham, it's great to be back after a long time.
Right, great. So Achal, like I said, you have mentioned in the past that systemic connections is one important lever. Can you first explain what is the meaning of systemic connections?
Okay, systemic connections consists of two parts, systemic and connections.
Right.
So we'll try to understand both of them. Systemic is derived from the word system, which essentially means a group of entities working together in tandem. And connections means the linkages between these entities while they are performing their specific function.
Right. So if I were to ask you, what is the meaning of systemic connections in terms of or in context of the business organization, how would you put it?
So Shubham, if you look around even here also, and I would like the viewers who are seeing this podcast, if they look around, you will find systems everywhere. So even the podcast apparatus that we are using right now is also a system. You are also a system, and I am also a system. After all, this is a human body. So likewise, business organizations are also systems. A system consisting of various entities, which we call as departments and functions, which are working in tandem and performing specific functions to achieve a certain goal. To understand this, let me use an analogy.
Sure.
And I'm going to, for the sake of the viewers, I'm going to take an example of a system which closely resembles the business organization. And this system is our human body. Now, in a human body, just like organizations have departments and functions, the human body also has departments and functions. For example, you have a respiratory system, you have a digestive system, you have a urinary system, you have a circulatory system. So there are many systems inside the body, right? These are the entities inside which are performing very specific functions. But at the same time, they are connected to each other in some way.
Right.
They are not in isolation.
It's interesting that you use the body as an analogy to the organization. But yeah, let's hear more about it.
Yes. Why I've used human body? Because if I talk in terms of the structure, how it is organized, and how it behaves, it is very similar to a business organization. And that is why I'm taking this example.
Okay.
So all these entities, these systems, subsystems, you can say inside the body, they are all connected in some way or the other. Now to understand how they are connected, so let me give you another example within this example.
Sure.
Suppose what I do is I artificially constrict the blood flow inside the blood vessel, say in veins or blood vessels, right? So what will happen? Just imagine what will happen if I do that.
Yeah, I mean, blood is very essential for every organ, every part of the body to work. So probably some damage to the organs or some part of the body might get damaged.
Yeah. So what may happen in such a case is that as soon as I put that constriction, I'm restricting the flow of the blood, right? This constriction will disrupt the blood flow. The result would be a flow distortion will start traveling from this place to all parts of the body.
Right.
This distortion will go to the heart, it will go to the liver, it will go to kidney, any organ, all the organs, right? What will happen is the blood pressure would increase. It can also lead to organ damage, maybe heart failure, and ultimately the body would succumb to this disruption caused.
Right.
Right. Now, a similar thing can happen in business organizations.
Okay. Can you explain how?
So there are the departments and functions,
Right.
And suppose and like blood flowing in a human body, what do you think is flowing inside the supply chain of the company's business organization?
Right. I mean, products or resources, some sort of resource.
Yeah. So I would say material.
Yeah, material.
So the material is flowing right from suppliers, to the production,
Correct.
To the business organization, then to the distributors or dealerships or OEMs. Now, if somehow at a particular point I create a constriction, just like we did in the case of blood vessel, right? So I am actually disrupting the flow of the material across the supply chain, and there will be a distortion which will start traveling, and this distortion will create effects everywhere. So that is the analogy I'm trying to bring out, is that how the flow disruption can cause problems there. It will be a problem for the organization. Say, for instance, the procurement department decides that I will control the inwarding of material. Suppose they decide, right? It will have an implication on the utilization of the lines of the production department. It will have an implication on the dispatches
Correct.
of the finished goods. It will have implications everywhere,
Almost
across all departments.
Yeah.
So a small constriction or a disruption can cause flow distortions everywhere, which can actually cause problems for the business organization.
Right.
So normally what we do in this case, it will be very interesting, in fact, for the viewers who are in these organizations, business organizations, that if you can map for each of your departments, right, the flow patterns of the material flowing inside the organization for their department, and multiple departments I'm talking about. For each department, you can map the flow of material flowing inside. And if that flow pattern comes out to be wavy or very curvy on a certain time horizon, then I think you have a problem, because it exhibits that there is a flow distortion within that department, and probably it is flowing across the organization. And you have a problem at hand.
Right. Sorry, just to clarify, Achal, you said you took an example of a supply chain or a manufacturing unit where the material is flowing. Does this concept also apply to all other non-manufacturing or non-manufacturing organizations where they probably don't have all these set of functions?
It is applicable everywhere where something is flowing.
Okay, right. Which is probably almost all organizations.
So all organizations. So for instance, if I have to take an example, if I look at the engineering and the design department, so what is flowing over there are drawings, right? If I take a project management company, what is flowing is work. If I take a sales and marketing department, what is flowing is sales inquiries. And,
right. Okay. Right. I get the point. Yeah.
So some medium is flowing, and whatever medium we are flowing, if we do some disruption to that flow of that medium, then it can cause problems.
So it's basically one common element which is flowing through the organization. As long as that is happening, it applies.
Yes.
Right. Okay. Mm-hmm.
So these flow distortions create trouble for the business organization.
So I understand what you're trying to say. An action or a constriction at some place in the organization will have an impact across the organization, right? Does it mean that anywhere the constriction happen, it will have an impact across the organization, everywhere in the organization?
Yes.
Or will it be very specific?
Okay. So there are two hypotheses in this. The two hypotheses something like this. Suppose I observe a distortion in a particular department. Where there's a flow pattern which is showing that the material is, there are material flow distortions in that particular department. Now, there are two hypotheses which we can arrive at. The first hypothesis is that this distortion which I'm observing in that particular department, or the flow pattern of the material I'm observing in this department, this could have been caused because of a cause being somewhere else and not at that department.
Right.
So the disturbance has traveled from that place up to this place. That is hypothesis number one. Hypothesis number two is that probably the cause itself is local. So the cause itself is in that department, creating a distortion. So this becomes the epicenter, and if the cause is there itself, this becomes the epicenter, and the shock waves of this or the distortions will travel from this place to all other places. So the key point when we are doing an analysis is to invalidate one of the hypotheses in this when we start doing an analysis. Whether the cause is local or whether the cause is non-local, which is traveling from somewhere. This is the kind of study and analysis that we have to do.
Right. So Achal, I understand, the way to identify and track the flow disturbances across the business organization. What I want to probably understand is what are the implications with such a phenomena, and also what are the implications of these flow disruptions that you are suggesting will happen in the whole system once I have validated or invalidated that one of the hypotheses is true, which is either the cause is local or it is not local.
So as I said earlier, the flow pattern, if it's too curvy over a certain time horizon, the flow pattern over a certain time horizon, if it's too curvy or wavy, then it exhibits that there is a flow distortion in that particular department of the organization. It could be at other places as well. Now, this flow distortion could have peaks and can have troughs. So, if you plot a curve, you may find that it has peaks and curves over the horizon. When a flow peaks, then in that particular department, which is the material flow has maximized and has reached a certain peak point. So, it would imply that particular department has gone into an overload situation. And if that particular department has gone into an overload situation, to handle that particular load, what they would do is overtime. So they will have an overtime cost.
Right.
They would also deploy additional manpower, extra manpower to take care of such peaks, right? A lot of freight expenses are also incurred, or expediting costs are also incurred in the process.
We typically see these actions being taken in organizations.
In the organization, just to handle that peak load which has come suddenly, because the material flow has peaked at that point of time and at that particular moment. On the other hand, of course, one more thing, when such a peak happens, it also gives a perception that the organization has less capacity. So, in terms of the strategy of the company, if they feel that because of this peak they have less capacity, they would go for an extra capex. While it may not have been required, but because of that peak happening,
gives me a perception that
my capacity is less, so they will go for capex investment. And on the other hand, if you see in the same time horizon, there is a trough happening, which means now the flow pattern is reached a level where the flow is very low at that point of time. Now, if a trough hits, right, what would happen is, in such a case, there will be a productivity loss. There will be starvation of lines. So the resources or the money that you have invested is all getting wasted, because now everything is starving at that moment. So you have situations of overload when the flow is peaking, and you have a condition of underload when the flow is at its minimal level.
Right.
So these would all come in terms of costs and capex across departments.
Right.
The key point that we must understand is that, you see, all these departments are not physically connected per se. If you look at, they're not physical. You can't see those connections or those linkages in between them. But the effect is being carried through to all the departments and functions by the material.
Which you were mentioning as systemic connections.
Yes. This is this is something not tangible that you can see. But yes, the material, because of its distortion at one place, is carrying that effect to all other places. So the causal influence is traveling all over the supply chain, all over the organization, or all through all the departments. That's the key that we must try to understand.
So I understand, the flow disruptions that are happening are important to understand these crests and troughs that are happening are very important to understand and probably solve for them as well. But how do we map these disruptions is also an important thing. Any suggestions on how do we map these disruptions well enough in an organization?
So, as I also said earlier, the first thing that you have to do if you are seeing there are issues or if you are seeing problems in your organization, perceiving those problems, the first thing that you must do is to department-wise, you should map the flow pattern on a certain time horizon. For instance, what can be done is, I'm just giving you one example, that I can take a month and divide into 4 time zones. Week 1, week 2, week 3 and week 4. And in that particular department, I can plot how the metal flow is happening across weeks. That will give me an idea as to how the metal is flowing in that particular department. Now, I can replicate the same and do it for all the departments together. So, I will have a set of flow patterns with me right in front of me. So, in procurement, there is this kind of flow pattern which is happening. In production, this is a kind of flow pattern happening. In dispatch, this is a kind of flow pattern happening. I can keep all flow patterns together and see. This will once you keep the flow patterns together, you will be able to come to a point where you will come to know that from where this distortion has got generated and it is traveling. The particular location of that triggering of that distortion. That location, once you come to know, right, is the place where the root cause is. This is how you start your analysis. And then you can hypothesize accordingly. So this is the first step that you must do.
Right. And I think that analyzing these flow patterns is imperative. You have to first understand the distortions very clearly.
Yes. Right? Because essentially these distortions are symptoms. Right? And we have to correct all the symptoms to arrive at the root cause. Unless until we connect the symptoms, we will not be able to know from where the cause is flowing. The causal influence is flowing, to be precise. So once we keep the flow patterns together, we know exactly from where the causal influence is flowing, and we can zero down onto that and then find what the root cause is, which has caused the disruption, and accordingly these distortions are flowing all across the organization. And that's why those peaks and troughs are coming all over the place.
Right. So you mean to say that, if I understand it correctly, these disruptions or flow distortions that are happening are probably happening because of one small change in the way things are being done at some place in the organization, and it is being carried throughout the organization, which is giving you the feeling that it is complex. However, it is actually very simple, that because of that one small thing, something else is happening. Is that the right understanding?
See, what happens is, in a business environments operating conventionally, when they see a symptom and effect at a particular place, they immediately choose the hypothesis that the cause also exists over there, and they start addressing the problem there itself.
Can you give an example from probably an actual work environment from a recent problem that you might have solved across an organization? Would that be possible?
Yeah, it is possible. So I'll give you an example. So what was happening was, this is a casting plant, right? And they were the problem in this casting plant was that they were observing mold cracks during the process. So there is a pattern which comes, the pattern formation happens, and then they pour hot metal. So when they pour hot metal, the mold would crack, right? So if all the molds crack, then their line stops.
It's a failure.
Because it's a failure.
Yeah.
It's a quality issue, right? The immediate and the obvious reason that comes to mind, the mold is cracking because there is a sand moisture issue. And that the sand quality is not up to the mark, right? The immediate hypothesis, and then people live with this kind of hypothesis without even looking at whether this is a reality or not a reality.
And they were trying to solve that.
And even though the tests claimed, because there are sand tests which happen, that the quality was all okay of the sand, but they then doubted the fact that probably the tests were incorrect, not done properly. It happens. The lab is not good or something like that, because they had their own biases of that that it is coming from the sand issue. It comes from the sand issue.
Yeah, it could. Yeah,
it could. Yeah, it's one of the hypotheses. Ultimately, when we traced as to what the problem is, so in both the cases, right, they assumed that the causal transfer was happening from the sand plant to the casting line. right? They had taken
Track that,
they had
yeah.
chosen that hypothesis where the causal transfer happens.
Okay.
However, in this case, the cause was local,
Oh, okay.
right? So it was the problem of the casting line where there was a huge misalignment of its parts which were causing the crack problem. And it was not a sand issue, though they thought that the cause was traveling, influence was traveling from the sand plant to this place. But actually, the cause was there itself.
Oh, so they were actually thinking that the cause is not local, but
Yeah.
it was actually local.
It was actually local. Normally, what happens, and now this is a very peculiar case, but normally what happens is people on the face of it take cause as local. Take cause as local, and they don't think about whether the transfer is happening from the other place or from the other.
Right.
But in this case, the reverse happened. But having said that, we should keep in mind both the hypotheses. We have to reject one of them. We cannot go that it has come from that place, it is not local, or it is low, or it is local, not come from that place. We have to evaluate both the options because that should be our starting point. So essentially, if I have to talk about a two-step approach, we should first map the flow and then look at the hypothesis. Which of the hypothesis is valid? It is coming from somewhere else, or it's a local issue which has become the epicenter and then making the effects travel all over the place.
Right.
If you can do that, then you can easily pin down on the location of the cause, and further analysis can help you get the cause as well. That is the essential part. The point that I want to make right now is that we should stop looking at organizations as a collection of departmental functions, not a collection,
Okay.
right? They are not working in isolation, right? So it's not a collection. It's not a collection of entities. It's a connection
It's a connection.
of departmental functions or a connection of entities. And this is very important for the organizations to understand. If they analyze that way, probably they will do a better job of locating the causes as well as deriving the right solutions.
Lovely. I love that it is not a collection but a connection of entities, and probably the way to demystify the complexity is very simple, but probably it just needs about little bit of practice and a little bit of thought, and probably the understanding that we might be biased with either of the hypotheses, like you said. So it is important to invalidate both the hypotheses, or one of the hypotheses at least, for that matter. Great. Thank you so much, Achal. This was really helpful, and I think a lot of insights for our viewers as well. I'm sure they're going to love it. We'll keep coming back with such episodes on the podcast. Thank you once
Sure.
again, Achal.
Thanks, Shubham.